So there's this thing called an R value, which basically tells you how strong the data is. So when I think of an R value, I think of how strong the data is. Okay, so when I say that, I just mean like, is something happening, or is it just like a conglomerate mess on the screen? So I'm going to come back up to these definitions in just a second. So basically, if as you look at A, I can't really draw a line, but the graph is doing something. It looks like it's almost got this like U shape to it. So if I had to draw like not a line of best fit, but like a curve of best fit, yeah, I would say it's something kind of like that. As I look at B, hopefully you're seeing that if you drew a line of best fit, it would be something in the middle there. We'll skip C for a second. In D, we would want to say that's probably increasing like that or has a positive slope. So hopefully you're noticing if this is a positive slope, then you could probably say that B has a negative slope. In A, the slopes are negative there, the slopes are positive there. And so you can't really say what's happening the entire time. And then C is an example of like that conglomerate situation I was talking about, where is the graph coming down like this? Is it straight across? Is it going up? I don't really know. So there's not a good line for this one. Not a good curve, not a good line, however you want to say it. And that's not a great situation to have to analyze, because it's like, oh, well, I don't really know what I can say. So we would say a positive linear relationship exists if they are ascending, if they're increasing, the values are going up from left to right. So hopefully you can see that would be graph D down there. A negative linear, so when you see the word linear, we should always think of the word line right there. So negative line, positive line, straight line to be more specific. So that negative direction, we already have said that that's the B graph there. The Y values are going down from left to right. And then nonlinear, okay? So that there can still be a relationship. So the two words are nonlinear relationship, so not a line, and then no relationship. We don't want to say no to A because there is some kind of thing happening, right? The data is telling us something that, if it was like buildings again, when you have a short building, it's going to have a lot of stories, but then for some reason, as you get bigger, it goes down. I don't know why that would ever happen, but then as you get even bigger after that, it starts to jump back up again. So the building would not be a good scenario for that, but it's just there is still some kind of relationship happening, and it's nonlinear, not a straight line. So that is graph A right there. And then lastly, the worst one would be C, because there's no relationship happening. We can't really say much about the data. It's just kind of there. There's not really a great relationship to say. So that R value that I referenced up there, so the R value comes into play with how to describe the data. So something that's like good, or they say perfect, a perfect negative linear relationship would be -1 right there. And a perfect positive linear relationship would be +1. So again, your R value it's going to be anything between, when it says that range right there, it's going to be anything between -1 and 1. So -1 is a best case scenario. 1 is also a best case scenario. Basically, like, does it fall on a straight line? The only time you'll get -1 or 1 is if it's falling on a straight line. 0 is when that there's no relationship there. So if you look at that third bullet point, if it's close to 0, that indicates that there is no, most likely not linearly related right there. Okay. And it's good to notice there that could apply to A, but it probably more likely applies to C. So it says this could mean that that they are related in some nonlinear way, or that they are not related at all. So again, R is what we're going to use to represent that, and it's called the correlation coefficient. Are things correlated? Can I see a correlation between things? Okay. So as I navigate that, take a second, see, you might have already looked at the answer key, but see if you could match any of these situations, I'll give you about maybe 2 minutes, or maybe a minute, and then to match the best you can. So the ones that I think are the easiest to deal with first are the negative ones and the ones, because that's when they're falling on a straight line. So that -1 and 1 are going to be the ones that are the most like clear as to what the answer would be. So hopefully we can jump to the fact that -1 should either be D or C, because they're perfectly on that straight line there. That -1, you can think about it as having a negative slope. Really, all of these have a negative slope. So it should be D as that first one. Okay. Um, if those are negative slopes, what these mean by being positive over there is that these are positive slopes. And so then R equaling 1 would be your C value right there. Okay, or C graph. Now, from here, it gets a little bit more tricky. So I'm just going to cross out D, cross out C. As I look at A and E are pretty similar. Okay, they're both going up. They're both have a positive slope. But as you can see, that this is tighter to the line. That's tighter than A. So if that one is tighter than A, that means it has a higher R value. It's closer to 1. So that means E will go with 0.9. Now, if you asked me, like, I wouldn't know that that's 0.9. Like if I didn't have any of this information down here, I couldn't say, oh yeah, it's 0.9. I'm only able to say that because in comparison to 0.5, that means since 0.5 is closer to 0 than 0.9, that means it's going to be less correlated. So this one right here is the least correlated out of all the positive ones. Okay, so that would be graph A. Using that same concept, the most correlated -1 was the negative right there. And then the next most correlated negative graph would be B. And then the least correlated one would be F. So hopefully that's making a little bit of sense that, again, if you had a graph like this, ... craziness, no clear way to put a graph, that would have an R value close to 0. If not 0, pretty close to 0.